Question 10 is a less familiar style, but really draws on some pretty simple ideas, so it should be fine. The function p of x is defined by that cubic function, where x is a member of the set of real numbers, and you're asked to find the remainder when p of x is divided by x minus 2. So you're using the remainder theorem here. So A part 1, you're just taking p of 2, and so I have 2 cubed, 8, minus 3 times 4, 12, plus 8 times 2, 16, minus 24. 8 minus 12 is minus 4, plus 16 is 12. 12 minus 24 is minus 12. Part 2, exactly the same approach. I'm doing p of 3, which is equal to 3 cubed, 27, minus 3 times 9, 27, plus 8 times 3, 24, minus 24, which is equal to 0, which tells me that x minus 3 is a factor, therefore, of p of x, which is useful for part B, because you're asked to prove that p of x has only one real 0. You know that real 0 is the one you've already found. So I want to factorise my cubic, then, effectively, and show that it won't factorise using just real numbers. So I'm going to perform a long division of polynomials. I'm going to divide my cubic by my factor, x minus 3. And my cubic is x cubed minus 3x squared plus 8x minus 24. So I get x squared, and that's x squared minus 3x squared, which is 0. So I'll then have plus 0x. So even though I've brought my 8x down, I'm going to have 0x squared plus 0x. So that gives me 8x minus 24. And then I have, as a consequence, plus 8. 8x minus 24. And thankfully, I have no remainder, because that's what I was expecting. So I can write my polynomial as x minus 3, x squared plus 8. And that's p of x. And x squared plus 8 equals 0 has no real solutions. And therefore, in total, there is only one real 0 as required. Part C. It's a bit of a weird question to ask, and tells me sort of by asking this, it's probably going to be used subsequently in Part D. Write down the transformation that will transform the graph y equals p of x onto that graph there. Now I notice that the new y is very similar to p of x. My cubic term is multiplied by 8, my squared term is multiplied by 4, my linear term is multiplied by 2, and my constant term doesn't change. In other words, I've replaced x in p of x with 2x. So this is p of 2x, and so my transformation is an enlargement in the x-axis of scale factor a half, y-axis invariant. That just means that my y values are not changing. And so part C seems a bit detached, but done. Part D, the random variable x follows a Poisson distribution with a mean of lambda, and you're given a very peculiar relation between those probabilities. So you're given in your formula booklet that for a Poisson distribution, px equals little x is equal to lambda to the x, e to the minus lambda, all over x factorial. So we're going to use that here. So I have 6 times, probably x is 3, so that's lambda cubed e to the minus lambda, all over 3 factorial, which is 6, is equal to 3 times the probability x is equal to 2, that would be lambda squared e to the minus lambda over 2 factorial, which is 2, minus 2 times probability x is 1, so that's lambda e to the minus lambda all over 1 factorial, which is 1, and then plus 3, lambda to the 0 is just 1, e to the minus lambda over 0 factorial, which is also just 1. I can simplify this, therefore. I'm going to divide by e to the minus lambda whilst I do so, because that's not helpful to me. 6 divided by 6, so I get lambda cubed is equal to 3 over 2 lambda squared minus 2 lambda plus 3. And so to solve this equation, I'd have lambda cubed minus 3 over 2 lambda squared minus 2 lambda plus, oh no, I'm completely wrong there, plus 2 lambda minus 3 is equal to 0. Now I look at this, and I'm thinking, well, they must have got me to do part C for some reason. And as I look closer, actually, I see that if I multiply this by 8, I get what I had in part C. So that is 8 lambda cubed minus 12 lambda squared plus 16 lambda minus 24 is equal to 0. Well, I have that here. That was P of 2x, which is now equal to 0. And I know that P of x had its only real root at x is equal to 3. So now I have, it's P of 2 lambda really, so now I have a root at 2 lambda is equal to 3, and therefore lambda is equal to 3 over 2, or 1.5. So an unusual set of questions here, but I can very much tell, because they're getting me to do some slightly strange things, that I'm going to be using those parts subsequently, and they serve as big hints for how on earth do I solve these things. And that's 15 marks, sorted.